You will learn about AKS Automatic, the new Azure service for running containers in Azure. With this new service, you will be able to create an AKS cluster with all the recommended tools that will be managed and supported by Microsoft. In Azure, we already have multiple servers for running containers. We have the services that are more IaaS oriented, more infrastructure oriented, and we have other services that are more developer oriented. Those are the PaaS services and the function as a service services. And typically the separation between those two worlds is that AKS is focused more on infrastructure, and we have container apps that focuses more on the platform as a service. The new offering AKS Automatic will sit between the two and will fill that little gap. So with AKS Automatic, at the end, you will have an AKS cluster with all the recommended tools that are installed. It means that because that's an AKS cluster, you still have access to the control plane, which you don't have with container apps. Container apps is well known for its simplicity because it's a service that is created for the developers. So you have multiple applications and multiple tools that are already packaged in and that are managed by the provider itself. AKS Automatic wants to do the same thing. When you create an AKS Automatic cluster, you would find already multiple tools and packages that are recommended. Those will be installed automatically for you. So the main advantage of AKS Automatic is that you will get the full power of an AKS cluster without worrying about installing additional tools into that cluster. AKS Automatic at the end is an AKS cluster. It means that we'll be using the same tools for deploying an AKS cluster, and when we want that cluster to be AKS Automatic, we just add SQ equal automatic, either in the command line as in this example, or also within Bicep or Terraform providers. So AKS Automatic is an AKS cluster that comes with multiple packages and tools and add-ons that will be installed by default by Microsoft, and they will be maintained and supported by Microsoft. Those tools, actually, there are plenty of these tools. So in terms of cluster, there are multiple choices that have been made by default. So for today, it supports Azure Linux, and you don't have the control over the upgrades. The upgrades will be managed and will be done by Microsoft, so the upgrades will be automatically done. However, you can choose when to apply those upgrades. And in terms of airbag, Azure Airbag will be enabled by default, and thus you will need to use Azure Active Directory, Azure Entra ID, in order to authenticate and also to authorize your users who wants to connect to the AKS Automatic cluster. You'd have local access disabled, and SSH will be disabled by default, and then you would have workload identity enabled in order to make it easier and more secure to connect to other Azure services that supports managed identity. Image Cleaner will be enabled by default in order to be able to remove the vulnerable images from the cache of the AKS cluster. Energy Lockdown will be enabled. This means that the managed cluster resource group or the node resource group will be locked by default. That will prevent unwanted suppression of that resource group. And in terms of workloads, deployment safeguards will be enabled by default in order to make sure that you deploy only applications that respects your best practices and your recommendations. And also Azure Policy will be enabled. With this feature, you will be able to apply policies into your AKS cluster from the Azure management plane. And also you'd have Azure Key Vault Provider add-on enabled. This uses the CSI driver in order to securely access Key Vault to retrieve secrets and TLS certificates from the Key Vault to be used by your application pods. Another set of tools that is enabled by default in terms of networking, first of all, we would have the choose for Azure CNI overlay powered by Cilium. That's the only option available today. We'll see later if we would have other options or not. But that's already a good option today, and that's what is recommended by Microsoft, and it have the full power of a Cilium plugin. And in terms of ingress, there is not yet support for application gateway or for application gateway for containers, but the only option that is supported here is the application routing add-on that uses Nginx ingress controller to expose the applications either internally or publicly through a public IP. And then in terms of egress, for today, the only option you have is to use a NAT gateway. So when you create an AKS Automatic cluster, you see that a NAT gateway is created by default in order to enable the egress traffic to go to the internet and to leave the cluster. So there is not yet support for UDR that enables you to route the traffic to an Azure firewall, for example. And for the control plane, it will be exposed through VNet integration. And with VNet integration, that is recommended by Microsoft, you'll be able to switch it to public or to private depending on your workloads and on your use cases. Now, in terms of the auto scaling, we would have the cluster auto scaling that is available by default in AKS that will be actually replaced by node auto provision. With node auto provision, you would have Carpenter running behind the scenes. With Carpenter, you will get better scheduling for your VMs, and your cluster typically will be cheaper to run. For auto-scaling the pods, we have here KDA that will be enabled by default, that will enable you to auto-scale your pods based not only on memory and CPU utilization, but also based on HTTP requests or also number of messages within a service queue. In addition to that, you would have the VPA vertical pod autoscaler. It will be enabled by default. And to make it easier for project teams to get the metrics and the logs from their clusters, in terms of observability, you would have managed Prometheus that will be enabled by default. So when you create an AKS Automatic cluster, you'd have a managed Prometheus instance with container insights enabled, and that will enable you to get the metrics and also the logs from your cluster. Those will be exposed through an Azure managed Grafana for the visualization and through container insights workbooks for visualizing the logs of your cluster. Then you can reuse those metrics and logs in order to configure alerts using Prometheus alert rules or Azure action groups. Follow me in the next video to see how we can create an AKS Automatic cluster. You will learn in this video how you can create an AKS Automatic cluster using the Azure command line. Because AKS Automatic at the end is an AKS cluster, so the only difference when we create that cluster is that we add here the SKU equal to automatic. After creating the cluster, we'll explore the additional tools that will be enabled by default within AKS Automatic. So let's get started. For the scripts that I'll show in this demonstration, they are available in this GitHub repository. And there you will find here the instructions for creating the new cluster where we specify the SKU to be automatic. And that's what I have run here inside my terminal. So I created first a new resource group, and then I create here the AKS cluster, adding the SKU to be automatic. And at the end of the creation, that takes almost about 5 minutes, you will have the JSON response that we all know coming from the AKS cluster that shows the different tools that are enabled by default. So here, for example, you can see the Azure CSI driver for Key Vault is enabled. The cluster is using managed identity. Azure policy is also enabled. OMS agent enabled with log analytics to collect the logs. The cluster uses multiple availability zones for better availability and high resilience. The cluster actually today is using version 128 of Kubernetes, and it's using the ephemeral OS disk for better startup time and better auto scalability. And as you see here, also it's using the Azure Linux OS system. Of course, there are lots of other tools enabled by default. Once the cluster is created, you will see that you would have multiple resource groups created. A first resource group where you would have the AKS cluster with the Prometheus resources. A second resource group that we all know, the managed cluster resource group that starts with MC. And then you would have a third resource group for Azure Monitor Workspace. Let's explore the first one here, where we would have the AKS cluster automatic. If I click here, then we would find the same user interface for a typical AKS cluster. If we go here to properties, we can see the different properties of the cluster. And then if we go to capabilities, we can see that container insights is enabled by default, Azure policy and managed Prometheus are already configured by default. Let's go now to node pools. So from here we can see the system node pool configured by default, and note here the scale method is set to manual because here It's not the cluster autoscaler who will autoscale the cluster, but this will be managed by node auto provision. It means that it's Carpenter who will go to autoscale our cluster. Next, if I go to cluster configuration, you will see that here this cluster is using by default the pricing tier standard. It's not the free one. This means you will pay for the control plane and you will have an SLA of 99.95%. Secret Store CSI driver is enabled by default to securely get secrets into your cluster. And note here, the automatic upgrade will be enabled by default, and here you can choose to schedule those upgrades. So Azure will upgrade your AKS cluster. Automatically, it will do that for you, but you can choose when you allow Azure to upgrade your cluster. You can also set up the security channel scheduler for updating the nodes of the cluster. And in terms of authentication and authorization, here the cluster is configured to use Microsoft Entra ID for authentication and Azure Airbag for authorization. This means that anyone who connects to the cluster needs to go through the authentication and authorization through Azure Airbag. So for myself, when I have first created the cluster in terms of access control, you will see that here you will be added by default to the role that is Azure Kubernetes Service Airbag Cluster Admin. So I'm there, which means that whenever I want to connect to the cluster, I'll be able to get the kubeconfig file. And next, if I try to do kubecontrol get nodes, then here I have two options: either to do device login using this code, or I can also use kube login in order to convert the kubeconfig file using credentials from the Azure CLI where I'm already connected using my account. And then we'll be able to get access to the control plane API in order to get the nodes of the cluster, for example. Next here, if we go to networking section, here you see clearly that this cluster is using Azure CNI powered by Cilium, and the API server is exposed publicly. And here, if I navigate to public access, you get the same information. But if I go to virtual network integration, you can see that VNet integration is enabled within this virtual network. Note here, ingress controller for application gateway is not yet ported. So for today, you should be using the application routing that uses the Nginx ingress controller. Great. Next, if I go to monitoring section, go to insights. From here, you can see that you can enable managed Prometheus. So we have actually a managed Prometheus instance created for us with a managed Grafana, and you can finish that configuration from here. So here, if I check, for example, kubecontrol get ns to get all the namespaces, you will see we have the kube system namespace, but we have also the app routing system namespace where the Nginx ingress controller is running there. Let's try kubecontrol get ingress controller, or simply get all the resources deployed within that namespace, and here we can see two pods running for Nginx ingress controller exposed through this public IP address. And that will take us to the second resource group, the managed cluster resource group, where we can see here two load balancers, one load balancer that will be used for the VNet integration, and another load balancer that will be used in order to expose publicly the services through the ingress controller. And we see here another resource that is a NAT gateway that will be used in order to egress the traffic from the cluster to the internet. So all that egress traffic will go through the NAT gateway. Cool. Let's go now to deploy an application into this AKS Automatic cluster. So here we have the sample application provided by Microsoft to deploy into AKS Automatic, where here it will just deploy some services, some deployments, services running databases. And at the end here, we would have the configuration for an ingress resource that is an ingress that will be exposing the web application through the web app routing ingress class name. Let's go to deploy that using kubecontrol apply-f and then the name of that YAML file. This will create multiple resources. At the end, if I do here kubecontrol get all, we can see the pods running. It will take a few seconds before they become running. So meanwhile, I can do kubecontrol get ingress. And here I can see my ingress resource that is called storefront that is running under this public IP address. Let's copy this IP, and from here we can get access to the web application that is exposed through AKS Automatic and through the app routing module through an ingress controller. So that was AKS Automatic with the pre-configured configuration.